Let's do a recap of section 6.3. So in 6.3, we talked about confidence intervals per population proportions. So population proportion, P, is the probability of success in a single trial of a binomial experiment. Point estimate for P, the proportion of successes in a sample, is denoted by P hat and is X divided by N, which equals the number of successes in a sample divided by the number in a sample. Point estimate for Q is the proportion of failures. So this one is denoted by Q hat right here, and is read as Q hat, and it is just as simple as 1 minus P hat. So in words, identify the sample statistic N and X. Number 2, we need to find the point estimate P hat and Q hat. So P hat is X divided by N, and Q hat is 1 minus P hat. We need to verify that the sampling distribution of P hat can be approximately normally distributed. This is how we do N times P hat, make sure that's greater than or equal to 5. We also do N times Q hat, make sure that is greater than or equal to 5. For number 4, we then find the critical value, Z, that corresponds to the given level of confidence, C. So we can use the standard normal table, or we can use Excel. Notice we're back to the standard normal table. So then we need to find the margin of error, E, which in this case can be found as E equals Z score times the square root of P hat times Q hat divided by N. Last but not least, we need to find the left and right endpoints and form the confidence interval. This can be done by P hat minus the error and P hat plus the error of both sides, adding and subtracting to P. So, for an example, in a survey of 1,219 U.S. adults, 354 said their favorite sport to watch is football. Find a point estimate for the population proportion of U.S. adults who say their favorite sport to watch is football. So first, we need to realize the important information, which is N equals 1,219 and X equals 354. Our first step is to find P hat, which is X divided by N, which in our case is the number of successes, 354, divided by 1219, and that gives us 29%. So in order to find Q hat, we just do 1 minus P hat, which is 1 minus 0.290402, which gives us about 71%. Next, we're going to have to verify the sampling distribution of P hat and see if it can be approximated by the normal distribution. So we take N, times it by this, we get 354, perfect, that's greater than 5. We do it and we times it by Q, which is 865, perfect, that's greater than 5. Next, we need to find the critical value on Excel. Then we can find our margin of error. So let's go to Excel, and we can open up Excel, and as we notice when we look at the bottom of our Excel file, there's one that says CIs for a proportion. So this is the CI calculator that we can find on our Blackboard. So when we click here, I can move this over here so I can look at my information I have right here. I need to know the sample proportion. Well, that was 0.29. I also need to know my sample size in this case, which was 1219. And I need to find my critical value. So I'm going to find my critical value by opening this up here, and we're going to use norm S IMV. We'll double click on it. So in order to find the probability for this one, I've explained it in 6.1 pretty well. So in here, I'm just going to go over the formula. You do 1 minus alpha. So in this case, our confidence interval is, if I can find it, must be 95. I didn't see that in our problem though. So let's do a 95%. So we can find in here with our critical value here. So I'm going to do 1 minus 0.025, and that's going to give us our 1.96. So when I write that in here, 1.96, you can see that it's going to give me my lower limit and my upper limit. Now if we're looking over here, we can plug it in by hand. We could do 1.96 times P hat times Q hat divided by N, and that equals our margin of error of 0.025. The next slide shows what happens when we add and subtract this margin of error, and we get the same numbers as when we did Excel. 0.265 and 0.315. And so those are right here in our lower and upper limits. So now let's go back to to PowerPoint. And we added and subtracted to both sides. Not to both sides, but to one side. P hat minus errors over here, P hat plus errors over here. That gives us our interval of anything that the point estimate can fall within. And so now we can say, in our interpretation of our confidence interval, with 95% confidence, you can say that the proportion of adults who say football is their favorite sport is between 26.5% and 31.5%. Another thing we learned in section 6.3 is how to find the minimum sample size needed and estimate for P. In 6.1, we found this also in another format. So for this one, we have to use N equals P hat times Q hat times the quantity of the z-score divided by the error squared. So the formula assumes you have an estimate for P and for Q. If not, use P hat as equaling 0.5 and Q hat as equaling 0.5 because 1 minus 0.5 is 0.5, so this is the only time that these two numbers would be equal. So here we have an estimate. We're running a political campaign in which to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum sample size needed. So first, they've given us a preliminary estimate of P hat being 0.31. So first we have P hat. Now we need to find Q hat, which is 1 minus P hat, which is 1 minus 0.31, which equals 0.69. Now we have our important information. The confidence level is 0.95, z-score 1.96 because we wanted 95%, and the standard error equals 0.03. Now we're going to take N and equal it to P hat times Q hat, whole thing times the z-score divided by the error squared. That gives us 913.02. Now we have to round up because we're looking for voters. If we do 913, we won't quite get our confidence level that we need. So we have to do at least 0.02 humans. Now we cannot do 0.02 humans, so we have to do at least 914 voters. So we need a larger sample size if no preliminary estimate is available. That's why we use 0.5 and 0.5 for our P and our Q. So this is all we learned in 6.3. We have found a point of estimate, we constructed a confidence interval, and we have determined the minimum sample size required when estimating a population proportion.